Okay. So last time we discussed about the Z transform, and we discussed about what is the need of for Z transform, what is the significance of Z transform. Uh, then we discussed about some few examples with Z transform with different signals. Okay. So today we going to devote on some more signals and its corresponding Z transform, and then the properties of region of convergence which is associated with Z transform. That is the actually key ideas. So as I already mentioned, your Z transform is nothing but when we take into consideration for discrete time Fourier transform, and in the discrete time Fourier transform, if you take your radius is equal to 1, so that gives rise to your Z transform. That means when your this Z transform is evaluated on a unit circle, that gives rise to your discrete time Fourier transform. Then why Z transform is needed? Because there are certain signals are there for which your discrete time the Fourier transform does not exist. For example, just like 2 to the power n un. So this is a discrete time signal where the un is your unit step function. So for this, your discrete time Fourier transform does not exist, but Z transform does exist. So in that cases, your Z transform is very very important. And if you can corresponding and the relation between Laplace transform with Z transform, if you can see the for Laplace transform, the region of stability is left half of S plane. Similarly, the region of stability in case of Z plane will be inside the unit circle. So left half of the S plane is corresponds to the inside of the unit circle in case of Z plane. So left half of S plane and inside the unit circle of Z plane, that corresponds to the same thing. That is the region of instability. Sorry, the region of stability. Okay, the gray color which you see here, so that is your region of stability. Whereas right half of S plane and the outside of the unit circle, that gives rise to your region of instability. So the blue region which you can see here, that is a region of instability. Okay, so this is the way how we can relate S plane with the Z plane. Okay, and this is a relation between Laplace transform with the Z transform. That means the left half of S plane in and the inside of the unit circle, that uh, gives you the region of stability, whereas the right half of a plane and outside of the unit circle, that is the region of instability. So this is the definition of Z transform. It is nothing but summation n is equal to minus infinity to infinity x of n z to the power minus n, and this is the your x of n and x of z is your Z transform pair. Okay, so x of n and x of z is your Z transform pair. So as I told that what is the relation with Z transform discrete time Fourier transform. If you substitute z is equal to r into e to the power j omega in the Z transform definition, then that gives rise to your x of r into e to the power j omega summation n is equal to minus infinity to infinity x of n r to the power minus n e to the power minus j omega n. Now let's say if r is equal to 1, then that gives rise to your discrete time Fourier transform. Okay, so your discrete time Fourier transform is obtained when at z is equal to e to the power j omega. So that means when the Z transform is evaluated on the unit circle, that corresponds to your discrete time Fourier transform. So that is the relation between Z transform and discrete time Fourier transform. And what is region of convergence? So Z transform is the region of convergence means the set of all value of Z for which your Z transform attains a finite value. So what value of Z the Z transform attains a finite value, that gives rise to your region of convergence. Now since the Z transform is an infinite power series, it exists only for those value of Z for which the series converges. Okay. So always remember that region of convergence means in Z transform, it that value of Z for which your Z transform exists, or you can say the Z transform attains finite value. Then we discuss some, let's say, this kind of signal, which is a, let's say, is anti-causal signal. For anti-causal signals, it is a discrete time sequence. So what is your x sub z? This is your x sub z, and what is the ROC? It for all z except z is equal to infinity. So remember that for left-handed, so it is what left-handed uh, sequence, that also called anti-causal sequence. So for anti-causal sequence or left-handed sequence, your region of convergence will be uh, all z except z is equal to infinity. Similarly, for right-handed sequence, the your region of convergence will be all z except z is equal to 0. Okay. Now, if you take into consideration of two-sided sequences, you see, it is two-sided sequences. Your origin is lies here. So in these cases, your x of z converges all value of z except z is equal to 0 and z is equal to infinity. So remember that for a right-handed sequence, the region of convergence will be all z except z is equal to 0. For left-handed sequence, your region of convergence will be all z except z is equal to infinity. For two-sided sequences, your region of convergence will be all z except z is equal to 0 and z is equal to infinity. Now, this part what we discussed is all about finite duration sequences. Okay, so these are all finite duration sequences. But let's say we have a infinite duration sequence where, let's say, this kind of causal signal where x of n is equal to a to the power n un. Okay, so if you can find its Z transform, so here we put xn is equal to a to the power n un. So and finally, if you can find it Z transform, then it comes to be 1 by 1 minus a z inverse. Or if you can simplify it, it comes to be z divided by z minus a. So what will be your ROC? Your ROC will be, now this will be defined when your AZ inverse mod will be less than 1, right? Or mod Z greater than A. That means your region of convergence will be outside this circle of radius A. So let's say this is the circle which has radius A. So your region of convergence, that means for the your x sub z or z transform to exist when your uh, your z is greater than the radius a. That means mod z when greater than a, that is your region of convergence. So the green region which you see here in this figure, so that is your region of convergence. Okay. Similarly, let's say we have a anti-causal sequence where y of n is equal to minus b to the power n u of minus n minus 1. So it is a anti-causal sequence. So if we find its z transform, so what will be here? It will be z divided by z minus b. But this will be converges when your b inverse z is less than 1, or mod z less than 1, mod z less than b. So your B is your actually your radius. Okay. So in these cases, for anti-causal sequences, your RSV will be, or your region of convergence will be inside the circle. Okay. So remember, for causal sequences, your region of convergence will be outside the circle. Okay, outside the circle of radius A. But for anti-causal signal, your region of convergence will be here inside the circle of radius b. Okay, so depending upon whether it is a causal signal or anti-causal signals, so your RSC is determined accordingly. So remember that for causal signals, your RSC will be outside the circle of that particular radius, and for anti-causal signal, your region of convergence will be inside the unit circle of that particular radius. Let's say we have a two-sided sequences where where let's say your signal is y of n is equal to a to the power n un minus b to the power n u of minus n minus 1, where b is greater than a. That means you see for this inner circle which has radius a and outer circle which has radius b, but and if you can see here, the radius b is greater than radius a. So in that case, yes, if you find its z transform and find it its region of convergence, so your region of convergence will be the ring which you can see here in the pink color, that is your region of convergence. That is between the radius A and B. So this is your region of convergence. That is mod Z greater than mod A less than mod B. So this is your region of convergence for two-sided signal. Very important thing that we need to know what is the stability of a system in terms of jet transform, and to find out in its region of convergence in the ROC. So remember this theorem, that it's very important. So let's say your h of n is the impulse response of a causal or non-causal linear time invariant system. Okay, what is h of n? The impulse response of a causal or non-causal linear time invariant system, and x of z be the z transform of h of n. Then what is the stability criteria? The stability of the system can be found out from the ROC using the following theorem. So what is the first point? If it is stable, that means if a linear time invariant system with the system function h of j is stable, or you can say BIBO stable, bounded input or bounded output stable, if and only if the region of convergence of x of z contains unit circle. So remember, the first condition is that if your jet transform is for a particular signal is stable, how we can get to know? First condition is that it should contain unit circle. Okay, the first condition, it should contain unit circle. If you know that the it contains unit circle, that means you can say it is a stable system. Another condition is that the LTI system, that means linear time invariant system, having system function h of z is stable if and only if all the poles of h of z are inside the unit circle. That means you find out the h of z, that we find out the z transform, and if you find that all the poles of z transform are inside the unit circle, that we can consider that it is stable system. So two criteria has to be satisfied. First of all, the your Z transform contains unit circle. So first condition. And second condition, that whether it is stable or not, your all the poles of Z transforms are inside the unit circle. So if these two conditions satisfied, then only you can confirm that your Z transform is a stable system. let's say let's say consider the stability of this impulse response. Let's say your impulse response h of n is equal to 2 to the power n un. Okay, now let's find it z transform. If you find it z transform, what will be z transform? It will be z divided by z minus 2. Okay, z divided by z minus 2. So accordingly, what is the your region of convergence? Your region of convergence will be mod z greater than 2, right? But whether in your this region of convergence, whether it contains unit circle? No, it's not containing unit circle, right? Your region of convergence is outside of this circle of radius 2, but your region of convergence does not contain the unit circle, right? This region is not containing. So that means this system is unstable. I hope all of you can understand that why it is unstable system. It's unstable because your jet transform that we get it here, your region of convergence does not contain unit circle. That is why it is unstable system. Okay, so always remember whether to know whether it is stable system or not in terms of jet transform. First, after getting the jet transform, you find its region of convergence. If in the region of convergence contain unit circle, then you confirm that it is a stable system. Okay. If it is not, then it is not a stable system. It is unstable. Just like that, if you can see in this example, your impulse response h of n is equal to 2 to the power n un. Okay. So if you can find its region of convergence, it does not contain unit circle. That is why the system is unstable. Now let's see the properties of region of convergence. So first of all, first property is that the region of convergence is a ring or a disk in the jet plate centered at the origin. Second thing, your ROC region of convergence cannot contain any poles. Okay. Third point is that if it is a causal sequence, as I said in I given an example, if it is causal sequence, your region of convergence will be entire jet plane except z is equal to 0. And if it is non-causal sequence, your region of convergence will be entire Z plane except Z is equal to infinity. And if it is a finite duration sequence, that means two-sided sequence, the your region of convergence will be all Z except Z is equal to 0 and Z is equal to infinity. Now this is all about your finite duration sequence. But for infinite duration sequence, if xn is an infinite duration, then or two-sided sequences, the region of convergence will consist of a ring in the Z plane bounded on the interior and exterior by a pole not containing any poles. Okay, so that is very important. And your region of convergence of LTI stable system contains the unit circle. That is very, very important. So for a stable system, your region of convergence of LTI stable system must contain unit circle. And another thing is that your region of convergence must be a connected region. So these are some of the important properties of region of convergence that you should know. Okay. Then we'll okay. Then this is the Z transform, and let's say this is the Z transform, and how to find out the inverse Z transform? You can find the inverse Z transform like this: x of n inverse of Z transform 1 by 2 pi j. Okay, 1 by 2 pi j x of z to the power n minus 1 dz. Okay, now this is the definition. You know, x of z, that is the Z transform of x of n is nothing but summation n is equal to minus infinity to infinity x of n z to the power minus 1. So this is your Z transform. But for inverse Z transform, how to find out x of n inverse Z transform of x of z, that is nothing but 1 by 2 pi z x of z to the power n minus 1 dz. Okay. Now this denotes your uh, over the integral. Okay, counter integration. Okay. So this is the Z transform and it is the inverse Z transform. And relation between Z transform and Laplace transform already discussed. So just like the your Laplace transform is developed as an extension of the continuous time Fourier transform, with your Z transform is developed as an extension of discrete time Fourier transform. In the continuous time case, the Laplace transform reduced to the continuous time Fourier transform. Your real part of s is equal to 0 by putting s is equal to j omega. Similarly, in the Z transform reduced to discrete time Fourier transform, that is mod z is equal to 1, that is z is equal to e to the power j omega. So just like that, for continuous, there are some limitations are there in continuous time Fourier transform for which your Laplace transform is there. Similarly, there are some limitations in the discrete time Fourier transform is there for which we use Z transform. Okay, and in the complex Z plane, if the mod Z is equal to 1, that refers to the circle of unit radius. Now, this unit circle in the Z plane is analogous to the imaginary axis of the Z S plane. Okay. Now, this is the region of convergence I already mentioned. Okay. Now, let's say x of n is equal to a to the power n un. So your Z transform will be 1 by a1 minus az inverse. Okay. So what is your original convergence will be mod z greater than mod a. Similarly, there is an important function for which you should remember its Z transform and its corresponding region of convergence. For example, what is the Z transform of unit strength impulse function? That is unit impulse function. So it will be 1. Okay, Z transform of unit impulse function will be 1, and your region of convergence will be all Z. What is the unit for what is the Z transform of unit step function in remember this is all are discrete time signals. Okay, so in this cases, what is your Z transform? It will be 1 divided by 1 minus Z inverse. And what is your region of convergence? Mod Z greater than 1. Similarly, minus u minus in minus 1, what is the Z transform? 1 divided by 1 minus Z inverse. And in this cases, your region of convergence will be mod Z less than 1. Okay. Similarly, there are some other important functions like a to the power n un, which we just now uh, described. It will be 1 divided by 1 minus a z inverse for mod z greater than mod a, and the z transform of minus a to the power n u of minus n minus 1 will be 1 divided by 1 minus az inverse. In these cases, it is mod z greater than a. So in these cases, a to the power n un is a causal sequence. But in these cases, minus a to the power n u minus n minus 1 will be anti-causal sequence. Okay. So you should remember what is the z transform. It's its corresponding region of convergence. Similarly, cos omega naught n un. What is the z transform? This one. 1 minus cos omega naught z inverse divided by 1 minus 2 cos omega naught z inverse plus z inverse square. Okay, for mod. And what is the region of convergence? Mod z greater than 1. Similarly, for sine omega naught n un, it will be sine omega naught z inverse divided by 1 minus 2 cos omega naught z inverse plus z inverse square for mod z greater than 1. So this is trigonometric terms. So this is corresponding z transform and the region of convergence associated with it. Similarly, the trigonometric terms multiplied with the real exponential. That means you see a to the power n cos omega naught n un. That means your trigonometric term multiplied with the exponential. So what will be your z transform? 1 minus a cos omega naught z inverse divided by 1 minus 2k 2a cos omega naught z inverse plus a square z inverse square. What is the your regional convergence? It will be mod z greater than a. Similarly, a to the power n sine omega naught n u of n will be a sine omega naught z inverse divided by 1 minus 2a cos omega naught z inverse plus a square z inverse square, which has region of convergence will be mod z greater than. So these are some of the important signals you should remember. It's a Z transform and its corresponding region of convergence. Okay. For example, let's take an example. Evaluate the Z transform for the signal. What is the signal? It's given 1 by 3 to the power n sine pi by 4 n un. Let's say this is one kind of signal and it is asked that let's say find out the Z transform. Okay. So as you know, Z transform of a to the power n sine omega naught n un is what? This one, right? A sine omega naught z inverse divided by 1 minus 2a cos omega naught z inverse a square z inverse square. Okay. So what is a here? A is 1 by 3. What is omega naught here? It is pi by 4. Okay. So just put all this value in the Z transform relation, then we can find the answer. And what is the Z transform here? Mod Z greater than A. What is A here? A is your 1 by 3. So like this way, we can find the Z transform. So if you can know for a particular signal with Z transform, you know the Z transform for a particular signal. So if relevant anything is asked, you can answer the question accordingly. So you should remember what is the Z transform for the given signal. Now let's discuss about some of the properties of Z transform. First property is that it obeys linearity property. Okay, so this linearity property tells that it that let's say your x of n x1 n, let's say one discrete time signal with a Z transform x1 z, x2 n with a Z transform x2 z, then a1 x1 n and a2 x2 n has Z transform a1 x1 z plus a2 x2 z. So this linearity property, it shows that it obeys superposition theorem. So that is the properties Z transform we should remember. Then another property is called time shifting property. Let's say your x of n has a transform x of z. Then using time shifting property, let's say this signal x discrete time signal is shifted by m unit. So x of n minus m will be what will be z transform z to the power minus m x of z. Similarly, if we find its frequency shifting property, if we let's say your x of n has z transform x of z, then if you multiply the signal x of n with e to the power j omega naught n, then what will be its corresponding Z transform? It will be x of e to the power minus j omega naught z. Or if you can just write in a way, let's say a to the power n x of n, then its Z transform will be x of z minus a. Okay, so these are all actually some of the frequency shifting property you should know. Similarly, time convolution property, just like in the convolution in time domain is always equal to multiplication in the frequency domain. Similarly, here also the same thing. Uh, the your convolution of x1n and x2n will be the multiplication in the z transform, that is x1z into x2z. That is your convolution in time domain is equal to multiplication in the frequency domain. Okay, let's say time differentiating property. So let's say time differentiating property, let's say you have x of n has a transform x of z. So let's say x of n minus x of n minus 1, what will be its corresponding z transform? 1 minus z inverse x of z. Okay, now this property allows linearity and time shifting property. Okay, now, what will be in the differentiation property in Z transform? Let's say your x of n has Z transform x of z, then n x of n. That means when the x of n is multiplied by n, then it will be minus z d d dz of x of z. Okay, differentiation of x of z with respect to z. Okay, so this is your differentiation in z domain. Let's say that is a signal you find. Let's say your signal x of n is equal to 1 by 5 to the power n u of n minus 3. Let's say find its z transform. How we can find out? Okay, now this x of n is what? 1 by 5 to the power n u of n minus 3. Okay, so that we can write it as 1 by 5 to the power 3, 1 by 5 to the power minus 3. Okay, and 1 by 5 to the power n, right? That e to the power n minus 3. We can make it it is the same, right? 1 by 5 to the power n, we can write it like this, right? 1 by 5 to the power 3, 1 by 5 to the power minus 3, multiplied by 1 by 5 to the power n. Okay, so into u to the power n minus 3. Now what it gives rise to? Your it will give rise to 1 by 125, 1 by 5 to the power n minus 3, right? U of n minus 3. So now if you can use time shifting property, then what will be your z transform? It will be 1 divided by 125 z to the power minus 3 into z transform of 1 by 5 to the power n u of n. Now this is the standard signal that we can find as z transform, 1 divided by 1 minus 1 by 5 z inverse. So what is your region of convergence then? Your region of convergence will be mod z greater than 1 by 5. Remember that for any, let's say for any signal the z transform is asked, means you have to find out the z transform obviously, but along with you have to find this region of convergence here also. So please remember always these things. Wherever you find z transform, its region of convergence must be specified. So this is one example how we can find the z transform of the given signal using the uh, property of z transform. So here we have used time shifting property. Similarly, how the when we find a z transform, we can find the inverse z transform also. That means let's say x of z is given, then how we can find out x of n out of x of z. Let's say there is a z transform x of z is equal to 3 minus 5 by 6 z inverse divided by 1 minus 7 by 12 z inverse plus 1 by 12 z inverse square. The let's say first condition is mod z greater than 1 by 3 arrow c. Like second condition is mod z less than 1 by 4. Third condition mod z greater than 1 by 4 less than 1 by 3. So this is the your region of convergence. So your x of z can be written uh, is actually this one. So using partial fraction, how we can write? Using partial fraction, we can write like this: 1 divided by 1 minus 1 by 4 z inverse plus 2 divided by 1 minus 1 by 3 z inverse. So if we find this corresponding inverse Z transform, so for mod Z greater than 1 by 3, when your ROC is mod z greater than 1 by 3, your inverse Z transform will be x of n 1 by 4 to the power n u of n plus 2 whole into 1 by 3 to the power n u of n. Let's say your region of convergence mod z less than 1 by 4. So your x of n will be minus 1 by 4 to the power n u of minus n minus 1 minus 2 1 by 3 to the power n u of minus n minus 1. If your region of convergence between mod z greater than 1 by 4 less than 1 by 3, so your inverse z transform will be x of n is equal to 1 by 4 to the power n un minus 2 1 by 3 to the power n u of minus n minus 1. Okay, so this is your different way how we can find out the inverse Z transform depending upon what ROC is given. Okay, so remember, whenever you find inverse Z transform, you should see what is the ROC is given. So based on that, you have to find its inverse Z transform. Now let's consider another example, or you can say another problem. Let's say where we can find the difference equation using Z transform. Now consider a linear stable discrete time system characterized by difference equation y of n minus 1 minus 10 divided by 3 y of n plus y of n plus 1 is equal to x. Let's say this is your difference equation. Okay. Now determine the impulse response h of n of the system. Now let's say if this kind of questions is asked, so you can and if it is asked that solve this question using Z transform, what you need to do, you have to take Z transform at the both side. Okay, when you take Z transform at the both side, find actually your h of z. Okay, and what is h of z? As I said, h of z is nothing but your that y of z divided by x of z, right? So here you can find y of z divided by x of z, that gives rise to h of z. Now when we take the inverse z transform, that gives rise to your impulse response, and that is nothing but h of n. Okay, so how we can do? Now let's take z transform on both sides of the difference equation. So this is your difference equation. So if you take the Z transform at the both side, that means left hand side and right hand side, and if you can use is the property. So what will be its Z transform? Y of n minus 1 will be Z inverse y of z, then minus 10 by 3 y of n had Z transform y of z, plus then what is the Z transform y of n plus 1, that is z y of z, and x of n Z transform x of z. Okay, we just only use the time shifting property of Z transform here. After using times the property of Z transform here, then we can find that the value as Z inverse minus 10 by 3 plus z y of z is equal to x of z. Okay, so after that we can find it h of z is equal to y of z divided by x of z. So if we can find the ratio, then your h of z gives rise to this value. Okay. Now, but it's asking impulse response of h of n. So what we can do, we can take the inverse z transform. So that gives rise to your impulse response. So your h of z can be expressed as z inverse 1 minus 1 by 3 z inverse 1 minus 3 z inverse. So using partial fraction, if we can use, so finally your h of z comes to be this
देखेगी
value.
ना इंटरेस्ट होगी सोचिए खेलते
So 3 by 8,
खेलने वाले
1 divided by minus
से
3
पूछ
by
के
8,
बच्चे
1 minus
किससे
1 by 3
किससे
z
लाइफ में
inverse,
करते हैं
plus 3 by
समझे
8, 1 minus 3 z inverse. Okay. Now
देव
this is,
किधर है
uh,
हार्ड पे
can you please,
हार्ड
students,
पे
can
तो
you please mute your mic?
हार्ड पे तो गाड़ी दिख रहा है मुझे से
Students, can you mute your mic?
आर्यन बॉल दे आर्यन बॉल
Okay, so if you can see here, so this is your actually your h of z. If you can find it, minus 3 by 8, 1 minus 1 by 3 z inverse plus 3 by 8, 1 divided by 1 minus 3 z inverse. Okay, so this is if that, if we take its inverse Z transform, then it comes to be h of n, that is equal to minus 3 by 8 1 by 3 to the power n un minus 3 by 8 3 to the power n u of minus 1. So this is your required answers. Okay, so now you can get to know how to find out the impulse response if the given given difference equation is given. Okay, so just take Z transform at both sides. After that, you find h of z, and after that, you take the inverse Z transform. That gives rise to your impulse response. Okay. Similarly, let's say another example we can take. Let's consider an LTI system now that produces the output y of n is equal to 10 whole into 1 by 3 to the power n minus 9 1 by 2 to the power n u of n. Okay, where the input is x of n 1 by 6 to the n u of n. Determine the constant coefficient difference equation that characterize the system. Let's say this kind of question is asked. So how we can do? The Z transform the input and output. Then first we have to find out what is the Z transform of the input and output. What is the input Z transform of this input signal? It will be 1 divided by 1 minus 1 by 6 Z inverse. What is the region of convergence? Mod Z greater than 1 by 6. And what is the region of what is the Z transform for this signal y of n? It will be 10 divided by 1 minus 1 by 3 Z inverse minus 9 divided by 1 minus 1 by 2 Z inverse. So what is the region of convergence? Mod Z greater than 1 by 3 greater than less than 1 by 2. Okay. So this is your actually your Z transform of the input and the output. Okay. So after this, you can find out what actually the constant difference equation of the the you can find out the constant coefficient difference equation. Okay, so how we can do? Therefore, the system function we can write it as x h of z is equal to y of z divided by x of z. Okay, so so what will be then? It will be coming as like this expression. Okay, now if you can use this, you can find that we can use the h of z is coming to be 1 minus 13 by 6 z inverse plus 1 by 3 z inverse square divided by 1 minus 1 by 6 z inverse plus 1 by 6 z inverse square. So what is your region of convergence then? Your region of convergence h of z will be mod z greater than 2. So if you can take the ratio of y of z and x of z, then it will become like this. And if you can take cross multiplication, then this is we can find this is the expression. And using time differentiation property, you can find the in this way. It's inverse Z transform. That is y of n minus 5 by 6 y n minus 1 plus 1 by 6 y n minus 2, which is equal to x of n minus 13 by 6 x n minus 1 plus 1 by 3 x n minus 2. Okay. Let's take another example. Let's evaluate the Z transform for this signal. How we can do? So let's say this x of n is equal to 1 by 3 to the power n sine pi by un. So if you can see, so this is the what you can say the standard form of the signal. So you can find the Z transform like this. Okay, what is the region of convergence? Mod z greater than 1 by 3. Okay, so I think this part is discussed. Okay, so once again, I am this difference equation using, and let me explain to you. So let's say we have a difference equation here where we have a linear stable discrete time system. So if you can see here, it is y n minus 1 minus 10 n minus 3 10 by 3 y 10 by 3 y of n plus y of n minus 1 using x of n. Then let's say you have to find out the impulse response. How we can find the impulse response? So remember the how we can solve this. First, you have to take the Z transform at the both side. Okay, the both side of this difference equation. So what will be then using time differencing property? What will be y n minus one Z transform? Z inverse y of Z. Okay. Then similarly, what is the Z transform of 10 by 3 y of n, 10 by 3 y of Z plus Z y of Z, which is equal to x of Z. Then you have to take y of Z common. Then what will be Z inverse minus 10 by 3 plus Z, which is equal to x of Z. So what will be your system function then? Your system function will be ratio of y of Z divided by x of Z. So that gives rise to your h of Z. So your h of Z is nothing but your system function. Or you can say your transfer function. Your h of Z is a transfer function or system function. So what will be this value? 1 divided by Z inverse 10 by 3 plus Z. But remember, what is the question ask here? It is asking h of n. So that means you have to do something that to find h of n. So how we can do that? You can do by taking the inverse Z transform. So that gives rise to your h of n. So h of n is nothing but inverse Z transform of h of Z. Now this h of Z can be expressed as like this. So you see h of Z, Z inverse divided by 1 minus 10 by 3 Z inverse to Z inverse square. So that gives rise to this expression. Then, if we use the partial fraction method, then it comes to be minus 3 by 8 divided by 1 minus 1 by 3 Z inverse plus 3 by 8 1 minus 3 Z inverse. Okay. Now, your h of z corresponds to a stable system if region of convergence has to be what? Within this range 1 by 3 and less than mod z greater than 1 by 3 less than 3. So what is your impulse response will be? Minus 3 by 8 1 by 3 to the power n un minus 3 by 8 3 to the power n u of n minus 1. So this is your impulse response. Okay. So hope you can able to understand how to find out the impulse response for the given system. If if the x of if the given difference equation is given. Okay, so it's very simple. You to find the z transform at the both side. After taking the z transform on the both side, then you find the transfer function and or system function that is nothing but your h of z, and then you find its inverse z transform. So your inverse z transform of h of z will give rise to your h of n, and your h of n is nothing but your impulse response. Okay. So, any doubt so far? Please let me know. Any doubt so far? Please let me know. Okay, if no doubts, then we can close this session.